Hello, everybody. Welcome to another installment of Biology from the Basement with your host, Mr. Andraco. Let's give it up to good old Bonesy here. We all love Bonesy. Working hard for us. It's going to be time to set you out to stud, though, Bonesy. Once we're done talking about the human body, we're going to maybe try to make it look a little earthier, a little eco-centric around here for our final unit on ecology. So, Bonesy, we do want to thank you for your service. I think everybody here agrees that you've been doing a great job. So, thank you very much. All right, so the purpose of this video is to go over these important terms real quick before we talk about the pancreas. The pancreas was always the most commonly tested question in the human body besides vaccines because it does a good job of relating homeostasis on the upper and lower levels. So it was always on the regents. I always go into it in great detail. Of course, you're not taking the regents in June, but I do want you to understand how this works. My understanding of the blood sugar levels and the pancreas have really helped in my parenting, needless to say. So anyways, that's what we're going to do. So let's have a fact of the day so that we can get started. And that is, which I never got to talk about, but one of the interesting ones is muscle facts. The scientific community does not agree on how many muscles our body has. The estimates range anywhere from 650 to over 900 muscles. Excuse me. The reason is because they don't agree on which muscles are one muscle or just layers of 2 or 3 different muscles and whether we should name them. So depending on which scientist you're talking to, they may divide up one giant muscle into many smaller muscles. The strongest muscle in your body is your masseter. The masseter is the jaw muscle allowed to put on about 600 pounds of pressure of force. So there's a couple muscle facts for you, which I forgot to give during the muscle lecture, but they're pretty cool ones. So let's get going through this real quick. Remember, the important terms here were glands produce hormones to travel in the blood till they find their target cells. Those hormones are messages that tell certain cells to speed up, slow down, start, and stop different processes that are taking place in the body. Okay, now these are specifically what are called endocrine glands, which we're covering in the endocrine system. We've already talked about exocrine glands in the digestive system, mainly because they are just products that are produced that travel through their own ducts to the active site where they are used, where the endocrine glands are producing hormones to travel through the bloodstream to find their specific target cell. We talked about the different glands yesterday, covered how the brain, the hypothalamus, and the pituitary gland are like the executive, judicial, and legislative branches of government, and the rest of these will be in your homework tonight, so you can go over those again. You'll get to see in more detail the adrenal gland, like I talked about yesterday, how it has many jobs because it really is 2 glands wrapped in one, that medulla in the middle, the cortex on the outside, but covering some very important functions. All right, here's what we're going to talk about. Now, the way that this works and the best way that I can explain it is through your day. Simple as that. Now, of course, this is going on the assumption that when you wake up, you eat some sort of breakfast. Your lifestyle right now may not be anything near normal of what it was or whatever normal is. Who cares? Anyways, listen to your body. But hopefully your day starts. We're going to work with it. Starts out by you getting up and eating some type of food, right? The food is going to contain carbs. Those long carbohydrates and those monosaccharides, right? The polysaccharides and the monosaccharides are going to go through your digestive system. They're going to get chopped up into monosaccharides, all of them, and they're going to enter into your bloodstream. This is going to elevate your blood sugar. We all like that part when our blood sugar goes up and we get a nice little food buzz and we're all in a good mood after dinner and we're like, yay, I'm so glad we're all best friends, right? And so while that's happening, your body says, well, this is a little bit too much sugar. We don't want to damage our nerves and other parts. So what we need to do is we need to store some of this blood sugar, I always say it backwards, the sugar in our blood for later. So insulin is released, and some of that sugar in the blood is captured and stored in your liver. And it's actually converted back from the monosaccharides in your blood, converted back into a polysaccharide, which we call glycogen. I know this is going to get wicked annoying in about 5 seconds. Glycogen is a polysaccharide that stores basically glucose for us for later use, right? Because we want to be down here at homeostasis. Sometimes we end up down here, sometimes we end up here. Our liver, as I said, has like 600 jobs. One of them is to store sugar for us in the form of glycogen. So, to recap, you eat food. Polysaccharides turn into monosaccharides. Monosaccharides enter the bloodstream. Blood sugar is elevated. Now, your pancreas is also a few glands in one. There are beta cells that release insulin. Insulin is the hormone. It is the message that says, liver, gather up some of this sugar in our blood. These monosaccharides, turn them into polysaccharides, bring us down to here, okay, so that we have a normal level of sugar in our blood so we have the energy to go on for quite some time, okay? Then we fast forward, say, for me, about 3.5 hours. Fast forward to about 3.5 hours, or even sometimes before that, it's happening and you don't even know it, your blood sugar decreases. You start to lose focus, you can't really pay attention, you're just kind of cranky, whatever it is, your body recognizes that as well. Now this is where this gets confusing because there's two different words that sound very similar. The alpha cells, the other group of cells in your pancreas that help with regulating blood sugar, they release glucagon. Glucagon is the hormone that goes to the liver and says, hey, liver, release some of that glycogen, that is that polysaccharide, as glucose back into the bloodstream because we're falling apart here. Okay? Bring us back up to that normal blood sugar level. Okay? So, real quick, blood sugar goes up. Beta cells release insulin. Insulin is the hormone that tells the liver to store monosaccharides as glycogen, bringing your blood sugar back down to a homeostatic level. When your blood sugar decreases, the alpha cells release glucagon. Glucagon is the hormone that goes to the liver and tells the liver to release the glycogen back as a monosaccharide like glucose into the blood, bringing your blood sugar back up to its homeostatic level. Okay? I hope that makes sense because that's how it works. It's about as simple as I can put it. And there you go. And that's all I wanted to cover for this lecture, was just to remind you what those other terms were and talk about that, and remind you that your ovaries and your testes are glands. And as well, what is it, 199 to 201 in your book, which wraps up the endocrine system, will be your homework for tonight. And tomorrow we will do a quick comparison of nervous and endocrine system, and then on to reproduction. So get all that work in. I'm going to make a separate post, but any zeros can still be turned into grades. So email me, talk to me if I made a mistake, which I've made a few, on forgetting to put the grade in for this or that. I'm getting like 100 emails a day, and I'm trying to get them all in. If there's a zero that you think you didn't deserve, email me. We'll take care of it. Okay, so check school tool, straighten this out, and we'll all have 100 this marking period. Wouldn't that be awesome? Okay, that's all we have for biology in the basement. So, and Draco out.